back, party people. 3.6, perpendiculars and distance. Are you ready? I am. All right, and we're back. We're back on this continent. Here we go. Have a little warm up here. Find x so that lines GH and RS are parallel. So there's GH, there's RS. Let's find x so that they're parallel. Well, I'm seeing here that we've got equations for, here, let me get this thing working. There it is. I'm seeing here we got equations for these angles here, GBA and SAB. Now, if these angles were congruent, these guys are alternate interior angles. They're interior because they're contained within the lines GH and RS. They're alternate because they're on opposite sides of the transversal XY, okay? If we can show that, if we can just say, hey, these guys are congruent, then we can show that GH and RS are parallel, all right? So let's just go ahead and say that the measure of angle there you are, GBA, it's getting squirrely, is equal to the measure of angle BAS, there it is. And so that's 9x minus 21 equals 7x minus 3. Once again, guys, these are alternate interior angles. Alternate interior angles, okay? Alternate interior angles. And we're going to use the converse of alternate interior angles theorem to show that these lines are parallel. So we're solving for x. I'm going to subtract 7x from each side and add 21 to each side. 2x equals 18, x equals 9. Now let's find, so that's x equals 9, and then once again, if these guys are congruent, then, or their measures are equal, then these guys, lines GH and RS, are parallel by the converse of alternate interior angles. Come on now, quit messing with me. Theorem. Excellent. Perpendiculars and distance. This is 3.6, guys. I hope you enjoyed the last video. Ooh, it was long and tiring to write. Once again, guys, I'm up at CISPUS with the 7th graders, tearing it up with that crew and Loretta. I'll see you soon. Here we go. 3.6, perpendiculars and distance. Goals, find the distance between a point and a line. Find the distance between two parallel lines. No big whoop. Let's just get on with it. A couple of key concepts and postulates here. Distance between a point and a line. The distance between a line, AB, and a point, C, not on the line, is the length of the segment perpendicular to the line, to the point. So the distance between this line, AB, and this point is this length of this perpendicular segment, okay? Here we go, perpendicular postulate. If given a line, M, and a point not on the line, P, then there exists exactly one line through the point that is perpendicular to the given line. Just one, exactly one. You're given a line M and a point P not on the line. There exists only one line that is perpendicular to M that passes through point P. Okay, moving on. Which segment represents the shortest distance from point A to DB? You can't see it, but there's a little X there that's the point of intersection between these things. Well, the shortest distance is the perpendicular distance from this point to this line. And so that's going to be line AX. Okay, which segment? Segment AX represents that shortest distance. Okay. All right. Now, number 2, line S. Oh yeah, this is pretty involved, guys. You ready? Okay. Line S, here it is right there, contains points 0, 0 and -5, 5. Find the distance between line S and point V, which is 1, -5. So the distance is the perpendicular distance, okay? So we need to find the line perpendicular, or the line segment that joins point V and S that is perpendicular to line S. So perpendicular, first let's find the slope of line S. So we're given 2 points, -5 and 5, and 0, 0. Okay? Let's find the slope there, all right? M equals y2 minus, oh my gosh, really? I don't want that. M equals y2 minus y1, so that's 0 minus 5 over x2 minus x1, 0 minus -5. So that equals -5 over +5, -5 over +5, which equals -1. That's the slope of line S. Now let's write an equation of the line T that is perpendicular to line S through 1, 5. So perpendicular to line S means that its slope is the negative reciprocal. So let's say M of line S, guys, I'm going to do something. I'm going to take off the keyboard here. Yeah, I'm going to go to tablet mode. Why not, right? M of line S equals what? -1. M of line T, which we have yet to draw, is the negative reciprocal. Okay, it's the negative reciprocal of line S. So that's just going to be positive 1 over 1, which equals positive 1. So that's the slope of line T. Now we need to find the equation for line T. So it kind of looks like this. Okay, it's this line right here. It's perpendicular. I don't know where it intersects with this line. I don't know if it's like, if its point of intersection on line S has integer values or if it's fractional values. I'm not sure, okay? But let's come up with an equation for line T. We know the slope, we know the point. So let's use point slope formula, M x minus x1. So y minus, so the slope we're going to use, or the point we're going to use is 1, 5. So y minus y1 is y minus 5 equals, and our slope is positive 1 times x minus x1. Okay, so this one is x1 right here, right? And the slope coming from here. So now I'm just going to go sideways here. Y minus 5 equals x minus 1. I'm going to add 5 to each side. Plus 5 plus 5. And y equals x plus 4. Okay, it's got a slope of 1. It's got a y-intercept of 4. 1, 2, 3, 4. So it actually passes right through that. Okay, now solve the system of equations for S and T to determine the point of intersection. Okay, let's solve the system of equations. We've got, let's see. Oh, well, I need, oh, I haven't written the equation of the line of S up here. I found the slope of it in step 1, but I never wrote the equation of the line. So I'm going to use this point and this slope and say y minus 0 equals -1 times x minus 0. Oh my God, look at that. It's so easy. Y equals -x. That's the equation for this line S, okay? The equation for line S is y equals -x. The equation, and I'll just go ahead and write those things over here. So line S is y equals -x. Line T is y equals x plus 4. Their slopes are negative reciprocals of each other, right? The slope of line S is -1. The slope of line T is +1. All right, let's solve this system of equations to see where these lines intersect, okay? So we're solving this system. So y equals -x. y equals x plus 4. What happens if I just add these equations together? What's going to happen is these x's are going to cancel out. So we're just using, it's not the substitution method, it's really the elimination method. All I have to do is add these things, and I get 2y equals 4, y equals 2. So their point of intersection occurs at y equals 2, okay? But now I need to find the x coordinate. So I'm going to plug y equals 2 in for the equation of line S to figure out what x equals on this line when y equals 2. So for line S, let's see, I've got to substitute 2 in for y, and that equals negative x. So what does positive x equal? X equals negative 2. All right, so we got y equals 2, x equals negative 2. This point of intersection, right, where these lines intersect, happens at negative 2, comma 2. And I'm going to go up here and write, so negative 2, 1, 2, up 2, boom. Right there. Whoops. Shoot. Pretty that up a little bit. Right there. There's my line. Oh yeah. Awesome. Cool. So now I've got the point of intersection for these two lines, right? They're perpendicular to each other. Now I'm trying to figure out the distance between these lines. I'm going to use the distance formula. I got 2 points, right? The distance, or not the distance between the two lines, I'm sorry, the distance between line S and point V. Well, now I have 2 points, right? I got 1, 5, which was given, and now I have this point of intersection, which is negative 2, comma 2. So distance between 1, 5 and negative 2, comma 2, that's a 2. Distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. D equals the square root, yikes. D equals the square root of, so x2, negative 2 minus x1, which is 1 squared, plus y2 is 2 minus 5 squared. Cool, we're doing it. Ow. All right. That's the square root of negative 2 minus 1 is negative 3. Negative 3 squared. 2 minus 5 is negative 3 squared again. Negative 3 squared. That's the square root of 9 plus, oh my gosh, plus 9. Still going. That's the square root of 18. Simplified, that's the square root of 9 times the square root of 2, which equals 3 root 2. Wow, that's a multi-step problem. Okay, so that's the distance, 3 root 2. Do you guys concur? Did I do that right? I sure hope so. Let's just back up. What did we do first? First, we found the slope of line S and then wrote the equation for line S. So the slope of line S is negative 1, and the equation for line S is y equals negative x. Then we wrote an equation for line T perpendicular to line S. First, we found the slope of the perpendicular line, which was the negative reciprocal. Okay, so the slope of line S is negative 1. The slope of line T is a negative reciprocal, which is positive 1. Then we use point slope formula with our new slope 1 and our point 1, 5 to build an equation for this line that's perpendicular to line S. Okay, y minus 5 equals 1 times the quantity x minus 1, and we get y equals x plus 4. I like it. Then we solve the system of equations for S and T to determine the point of intersection. Okay, the point of intersection for these two lines, S and T. So we solve the system of equations using elimination. We stack them, y equals negative x, y equals x plus 4. We add them together, the x's cancel out, 2y equals positive 4. I'm just going to go ahead and write that 4 right there, right? Okay, 2y equals positive 4. So y equals 2. There's my y equals 2. I plug that back in for line S to find my x value. 2 equals negative x, so x equals negative 2. So now that's our point of intersection. Then I find the distance between point V and our point of intersection, which is the which is the perpendicular distance. And I go, let's see, x2 minus x1 squared, negative 2 minus 1 squared is 9. y2 minus y1 squared, that's 2 minus 5 is negative 3 squared is 9. 9 plus 9 is 18. Simplify it, 3 root 2. Woo! Done. Equidistant. The distance between two lines measured along a perpendicular line is always the same. Okay, the two lines are parallel if they're equidistant. So if two lines are parallel, they're equidistant. Okay? Distance between parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So here are some parallel lines. Here's a point on one line. Let's call this line X. Let's call this line Y. The distance between the two is the perpendicular distance. Okay? All right. And two lines equidistant from a third. In a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So here's a third line that runs in between there that is equidistant from both lines X and Y. Okay, here we go, guys. Oh man, this is it right here. This is a big one, guys. Let's get through this. Okay, find the distance between the parallel lines A and B. There they are. Let's zoom in a little bit here. A and B, whose equations are y equals 2x plus 3 and y equals 2x minus 1 respectively. They both have the same slope of 2, okay, and different y-intercepts. They're parallel. We're trying to find the distance between them. So, seems like we need to find a line perpendicular to both of them, then find the points of intersection of that perpendicular line, in this case P, intersecting here. If we can find those 2 points of intersection where P intersects A and B, then we can find the distance between those points. You can put P anywhere you want as long as it's perpendicular to both A and B, right? So P could intersect up here, it could intersect up here. It doesn't matter. The perpendicular distance between these two lines is the same. Okay, hint, give P the same y-intercept as either A or B, so that you have one easy intersection point at that y-intercept, and you have B to easily write the equation. I think that's a smiley face. All right. So, yeah. So let's go with a point we already know. So once again, write an equation for line P. Well, first of all, let's find the slope of P. So M of P, okay, is the negative reciprocal of M of the slope of either of these two lines. And so the negative reciprocal of 2, so let's do this. Slope of A and B equals 2. Slope of P is negative 1/2. Make sense? The negative reciprocal. Now, let's use a point, okay? Let's use a point on line P. It can be any point, and our point slope formula to get the slope, to get the equation of line P. So it looks to me like the y-intercept of line B is -1. So that would be point 0, -1. So let's go ahead and use that point and this slope to build our equation for line P. Y minus -1, that's my y1, equals -1/2 times the quantity x minus 0. Okay? Once again, I'm using 0 and -1 for the point, because line P is going to intersect right here at this y-intercept of line B, 0, -1. So now I have y plus 1 equals -1/2 x, and then y equals -1/2 x minus 1. That's the equation for line P. All right? Now use a system of equations to determine the point of intersections of line A and line P. Okay. So here's my equation for P, here's my equation for A, Let's boil these babies down and figure out where they intersect. All right, so y equals 2x plus 3, y equals negative 1/2 x minus 1. We're going to use the elimination method again, but first we're going to multiply this equation by 2. So this is line A, this is line P, right? I'm going to multiply this guy by 2. And now we have y equals 2x plus 3, and we have 2y equals negative 2x. Oh, is that right? Oh, I need to multiply this thing by 4, don't I? I do. I need to multiply it by 4. Sorry about that. 4y equals negative 2x minus 4. There we go. Now we can add those things together. 5y equals 0x minus 1. Oh dear, look at that. What does y equal? Look at that point of intersection. Look at that point of intersection. Y equals negative 1/5. Okay, once again, we're trying to determine the point of intersection of lines A and P. We have the y value now. Let's take that value and plug it in for y on one of these equations. So let's go line A, and I'm going to say negative 1/5. So I'm taking y and I'm plugging it in for y in equation A equals 2x plus 3. I need some space here. All right. Cool. I'm solving for x. Subtract 3, subtract 3. Negative 1/5 minus 3 equals 2x. I need a common denominator of 5. So negative 1/5 minus 15/5 equals 2x. Negative 1 minus 15 is negative 16. Negative 16/5 equals 2x. Now I'm going to multiply each side by 1/2 to get rid of that 2 there. And I get negative 8/5 equals x. I have a value for y. I have a value for x. So this point of intersection is negative 8/5 and negative 1/5. Let's look at our drawing to see if that actually makes sense. Negative 8/5 is just under 2, negative 2. So I'm going left 2. Yeah, that looks about right. And down 1/5 to the left 8/5 down. That looks about right. I'm feeling good about that. Boom, box it. Now use the distance formula to determine the distance between the 2 points where P intersects A and intersects B. So I got one point of intersection for line P and line A. I have another point of intersection for line P and line B, right? They intersect right here. Let's use those points and the distance formula. Okay, so I've got 0, negative 1, and I've got negative 8/5 and negative 1/5. Oh, this should be fun. Use the distance formula with some fractions. Okay. Distance equals x2 minus x1, negative 1/5 minus, x2 minus x1, negative 8/5 minus 0 squared, plus y2 minus y1, negative 1/5 minus negative 1 squared. Ooh, that almost got me. Okay. Going sideways. That's the square root of, let's see, negative 8/5 squared is, what is that? 64/25. 64/25, right? I'm squaring 8, I'm squaring 5, plus, oh my gosh, look at that. I got to find a common denominator. What a mess, huh? That's basically, oh, I know what that is. Negative 1/5 plus 1 is just 4/5 squared. So that's the square root of 64/25 plus 16/25. Oh, that's kind of nice, though. At least they have common denominators, right? And that's the square root of 80/25. Ooh, I don't mind what's happening here. This could be a lot worse. Which is the square root of 80/5, right? Because we take the square root of 80 and the square root of 25. And now let's find the square root of 80. That's the same as root 16 times root 5/5. That's 4 root 5. Give me some space here. Over 5. 16 times 5 is 80. Oh my gosh. We made it, guys. Woo! What the heck did we just do? How about a recap? We're given two parallel lines. We want to find the distance between these two parallel lines. So what we do is we create a line perpendicular to these two lines by finding, we get a slope, a negative reciprocal slope of the given slope for lines A and B, and a point of intersection with one of these lines. We build an equation for this line. We find where that line intersects the two lines. We find those points of intersection, and then we find the distance between those 2 points of intersection. Yikes, 4 root 5/5, no big deal. Guys, you're ready for your homework assignment. I hope you enjoyed it. Have fun out there. We'll see you soon.